Hello, in this lesson we're going to learn about inverse functions. Inverse functions are functions that reverse the action of another function. Throughout this lesson we will learn how to recognize inverse functions, verify them, and find them algebraically. So let's get started. In this section we will learn how to find inverse functions informally and verify that two functions are inverses of each other. We will also use graphs to verify that two functions are inverse functions of each other. Next, we will use the horizontal line test to determine whether functions are one-to-one. And finally, we will learn how to find inverse functions algebraically. An inverse function is denoted by f inverse of x, and it reverses the action of a function f of x. For example, the function f of x equals x plus 4 has an input set a, which is equal to 1, 2, 3, 4. This will map out to the output set b, which is equal to 5, 6, 7, 8. And it can be written as f of x equals x plus 4. So the ordered pairs are 1, 5, 2, 6, 3, 7, and 4, 8. To form the inverse function, we switch the coordinates of each ordered pair. So the inverse function becomes f inverse of x equals x minus 4. And the ordered pairs become 5, 1, 6, 2, 7, 3, and 8, 4. Notice that the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. Function f and its inverse f of inverse undo each other. When we form the composition of f with f inverse, we obtain the identity function. For example, the function f of x equals x plus 4 has the inverse function f inverse of x equals x minus 4. So we have f of f inverse of x equals f of x minus 4, which is equal to x minus 4 plus 4, which is equal to x. We also have f inverse of f of x, which is equal to f inverse of x plus 4. And this is equal to x plus 4 minus 4, which is also equal to x. Since both compositions simplify to x, the functions are inverses of each other. Now let's verify inverse functions. We want to determine which function is the inverse of f of x is equal to x over x minus 2. We are given g of x equals x minus 2 over 5, or h of x equals 5 over x plus 2. First, let's test g of x. We substitute g of x into f of x, and after simplifying we get 25 over x minus 12. Notice that this does not simplify to x. So since f of g of x does not equal x, g is not the inverse of the function. Now let's test h of x. We substitute h of x into f of x, and after simplifying we obtain x. Since f of h of x equals x, h is the inverse of the function. The graph of an inverse function is a graph of the original function reflected over the line y equals x. You can graph the inverse by switching the ordered pair ab from the original function to ba. In this example, the point 2, 4 on the original function becomes the point 4, 2 on the inverse function. A function must be one-to-one to have an inverse. This means that each y value corresponds to exactly one x value. To verify if a function is one-to-one, we use the horizontal line test. If any horizontal line intersects the graph more than once, then the function fails the test. The graph on the left is not one-to-one because the horizontal line intersects the graph more than once. The graph on the right is one-to-one because each horizontal line intersects the graph no more than once. We can find a function's inverse algebraically by following these steps. First, use the horizontal line test to determine whether the function has an inverse. Second, replace f of x with y. Third, interchange x and y and solve for y. Fourth, replace y with f inverse of x. And finally, verify that the functions are inverses by checking that f of f inverse of x equals x and that f inverse of f of x equals x. Let's find the inverse of the function f of x equals 5 minus x over 3x plus 2. Notice that the function passes the horizontal line test. First, replace f of x with y, so we get y equals 5 minus x over 3x plus 2. Next, interchange x and y, so we get x equals 5 minus y over 3y plus 2. Now, multiply both sides by 3x plus 2 to get x multiplied by 3y plus 2 is equal to 5 minus y. Distribute to get 3xy plus 2x equals 5 minus y. Collect the terms with y and factor out the y. This will give us y times 3x plus 1 equals 5 minus 2x. Now solve for y, and we get y equals 5 minus 2x over 3x plus 1. Finally, replace y with the inverse notation. F inverse of x equals 5 minus 2x over 3x plus 1. And this concludes our lesson on inverse functions.